This is the video on three different methods. So you can actually compare when I do the prime factorization and the long division, the process will be like very lengthy and I'll be taking a lot of time. When I show you the third method at the end of the video, you will realize that there are so many smart things which we all can learn. So friends, talking about these short tricks, I should tell you that we have this short tricks for quantitative aptitude ebook which comes along with the reasoning course combo, and in the reasoning we have 18 different chapters. In this quantitative aptitude we have covered 24 chapters which are like normally asked in all the quant exams, and it contains over 300 short tricks and 10x faster calculations. That's what we target using this. If you are preparing for any of these exams, you can see the list of exams which it targets. You have to get a copy of this, and I'm sure for school students also, for preparing various Olympiads and then NTSC exam, all these exams are really important for every student. So if you want the combo, if you want to go for this, you need to send me a message on WhatsApp 9896 369963. that is the WhatsApp number. Send me a message now. I'll tell you how to get a copy of this amazing combo which will be very beneficial for all the school students, all the school teachers, also the mathematics teachers, right? So friends, what is the concept of the trick which I am going to take up for this video? So when I talk about the concept of finding the HCF, the first thing that comes to my mind is prime factors. So prime factorization method, this is the most basic method taught at school level, but this prime factorization method works for small numbers. When the numbers are like it's easy to factorize them, but when the factors itself are big, like maybe some number is divisible by 17 directly, so how will the students make the factors of that 4-digit number or a 5-digit number? Very difficult, right? So works for numbers up to say 100, 200 or maybe 300, 400 also. But beyond that, you need to have the second method, which is the long division method. So long division method is the second method which all the students study at school level, and this basically is like you have three numbers in ascending order, say. So you take the second number and divide it by the first number. So you perform some kind of steps, I will demonstrate that using three numbers, and then you get to the final divisor, and this final divisor is to be combined with the third number, and again final divisor is to be found out, right? So that will give you the HCF. Obviously we will be illustrating everything using prime factorization and using long division because we want to find the efficiency of the third method, right? So the third method, which works for all numbers and avoids the use of prime factorization and long division, is the method which we are going to call the exclusive method. So you need to watch the video, and I'm taking three numbers now and you will see the efficiency of that method, right? So let's see the numbers. Look at the numbers here: 1080, 1350 and 3675. So how are you going to find the HCF? Very few students will say prime factorization method, because 4-digit numbers, making prime factors can be a really tricky job, and if you get one factor wrong, everything goes wrong. But let us try. That's what we are going to do in prime factorization. You will see, even if I have made the prime factors already, how much time we are going to consume to get to the final answer of the HCF. Now the first number 1080, I want to write the factors, then 1350 again the factors, and then 3675 I want to write all the factors. Now for the first one, 1080, I think this is going to be 2 times 540, so 2 times 270, so 2 times 135, so 45 into 3, so 3, and 45 means 9 into 5, so 3, 3 and 5. See, I made all the prime factors of 1080. Likewise 1350 will have a 2, so this is 675. 675 goes into 3, right? So probably I'll have 3 3s here. So I'll write all the 3s together, and after that we will have 2 5s. So 1 5 and 2 5s. And 3 6 7 5, if I want to make the factors, it is an odd number, so divisible by 12 and 921. So divisible by 3, and then the remaining factors are like 5 times 5 times 7 times 7. Now see, I have made the factors already, and that's why I have taken less time. But if you want to make the factors, even the school students, class 6, class 7 students, they are going to consume a hell lot of time to make the factors itself. Now we will write it in exponential form. So how many 2's? 3 2's, so 2 raised to power 3. 3 3's, so 3 raised to power 3. And a 5, so 5 raised to power 1. This is 2 raised to power 1. And then we have 3 3's, so 3 raised to power 3. And then we have 2 5's, so 5 raised to power 2. Likewise here we have 3 power 1. And then 5 power 2 and 7 power 2, right? Now if I want to find the highest common factor of the 3 numbers, I just have to pick up which factors are common in all the numbers. See, there is no 2 here, so this is cancelled out, right? Now between the 3's, we have 3 power 3, 3 power 3, 3 power 1. So the common factor is just 3 power 1, okay? And then between the 5's, 5 power 1, 5 power 2, 5 power 2. So the minimum power is 5 power 1, and the 7 is not a common factor. So the answer for the question is 3 5's are 15. So the highest common factor of the numbers is 15. Oh, that took around like 3 minutes, right? 3 numbers, 3 minutes. But there are efficient methods. You call them efficient, right? We want to try the long division method for the same 3 numbers, 1080, 1350 and 3675. Now let's see whether that is more efficient or not, right? So for that I will be taking the second number. Second number is 1350. So 1350 to be divided by 1080, which is the first number. So 1 times is 1080. So when you subtract, you get 270, right? And so this number 1080 becomes the dividend, and we have to do how many times? 4 times, and that gives exactly 1080. So fortunately for me, the division terminated here, and the last divisor is 270. So now what I do is 270 becomes the divisor for the third number 3675. So now I have to do the division process all over again. So 270 ones are 270, so I can subtract. This becomes 7, and this is 16 minus 7 9, so 97, and I have to bring the 5 down, right? So 273s are 810, so this gives me 5 6 and 1 165. And so now this divisor 270 becomes the dividend. 270 comes here, so 1 times is 165. So this gives me how much? 270 minus 165 is 105, right? And now 165 becomes the dividend, and then again 1 times is 105, which gives me 60. Now 105 becomes the dividend, so I'll write it here 105, and the divisor is 60. So 60 1 times is 60, which gives me 45. Now 60 becomes the divisor, so you have to keep on doing until you get the remainder as 0, right? 45 1 times is 45, so you have 15, and finally 45 becomes the dividend, so 15 3 times is 45, and you have a 0. So which is the last divisor? The last divisor is 15, and therefore the highest common factor of the 3 numbers is 15. So you can see, even if I have used single steps for division, I took so much of time. And just think about 11-year-old or 12-year-old student or 13-year-old student looking to crack this question through long division. It is going to take 4 to 5 minutes at least, and that too the surety is not there that you will get the correct answer. And now comes the climax. The climax of the video, I told you, the third method, which is the minimum difference method, and For that, I would just like to tell you that why this minimum difference is used. If the difference between 1080, 1350 and 3675, the consecutive differences, if I take difference like this and difference like this, right? Since I have arranged them in ascending order, the difference between the first two and the second two, one of them will be the lower one, right? So I have to take the minimum difference. That means the difference which is minimum, either it is between second and first, third and second, or third and first, right? So minimum difference I can see here is 1350 minus 1080, right? And that minimum difference comes out to be 270. And you can see the difference between these two numbers is like in thousands, and difference between these two is further more. So the minimum difference is between the first two numbers only, and that is 270. Now the concept which I am going to use here is the highest common factor of all these numbers is a factor of the minimum difference. That means now my answer is going to be a factor of 270 only. So what I will do is I will reduce this 270 in terms of its prime factors. So 270 is 2 times 135, right? So 135 is 45 into 3. So 3 times 45. 45 is 9 times 5. So 3 times 3 times 5. So I made the factors of 270. Now the three numbers here, 1080, 1350 and 3675. Now let's consider one factor at a time. If you see this number 2, it divides this because it's an even number, divides this because this is also an even number, but it doesn't divide this because this is an odd number. So if any factor doesn't divide even one of these numbers, then you have to cancel it out. Because 2 doesn't divide 3675, I cancelled out the 2. Now if you watch this number 3, 8 plus 1 is 9, so divisible by 3. 5 plus 3 plus 1 is 9, divisible by 3. 6 plus 3, 9 plus 12. 9 plus 12 is 21, divisible by 3. So all the three numbers are divisible by 3. So I will put a circle over 3 and just write the quotients. 3 3s are 9, 3 6s are 18, 0, right? 3 4s are 12, 15, 5 and 0. 3 1s are 3, 3 2s are 6, 3 2s are 6 and 3. See, I divided all the numbers by 3 and I have put a circle because all these numbers were divisible by 3. Now let's consider the next factor 3. Does it divide this? Yes, it does. 6 plus 3 is 9. 5 plus 4, 9. Divisible. How about this? 5, 6, 7, 8, 9, 10. So this number is not divisible by 3, right? So next 3 is cancelled out because it doesn't divide this. And automatically the next factor also gets cancelled out because it doesn't divide 1 to 2, 5. And finally, you have the factor 5. Ending in 0, divisible by 5. Ending in 0, divisible by 5, ending in 5, divisible by 5. So you have a circle over these and you don't need to divide them now because there are no more factors here. So what is the HCF? The highest common factor of the numbers are the numbers which you have circled. So 3 times 5, and that answer is same as what we obtained through the prime factorization method and through the long division method. Now this is how it works, and you can see the amount of steps, amount of work we have done here as compared to the amount of work we did here. Look at this long division method. We got the answer all right, but the number of steps in division were huge, and that is why the time consumption was too much. Likewise, the prime factorization, since I have written all the factors here directly, so it looks easy, but making all these factors itself is a terrible job, time consuming job, and then putting them in exponential form, finding the common factor, that will take too much of time. And therefore this method of minimum difference works the best in case of 4-digit numbers.